Hello friends, in this video we will start with the new topics, new classes related to Java input output in detail. Okay, we were talking about character based classes, character oriented classes or streams. Okay, for worldwide users of Java. So we will continue with that. We will see now the console class. Java 6, that is Java 6 adds the console class in that. It is used to read from write to the console. Okay, it implements the flushable interface. Console is a primarily convenience class because most of its functionality is available through system.in and system.out. Okay, so simple methods are available and standard output device is console. So we will read from console and we will write to the console. And also, important thing is it implements the flushable interface. It was not available before Java 6. Okay, so if you want to add or use the console class, you have to use Java 6 and beyond in your laptop or desktop. Okay, next. Okay, you can simplify some types of console interaction, especially when reading strings from the console. Okay, so system in and system out are the convenient methods we are using since the chapter 1 of this course. Its use can simplify some types of console interaction, reading strings from the console. Console supplies no constructors and it is obtained from system.console method. So method is static console which returns the console object. Okay, but it has no constructors. If console is available, reference is written, otherwise null is written. Okay. Console will not be available in all cases. If null is written, no console input output is possible in that particular case. So first you have to check if console is available or not, and then you will interact with the console. So now in the upcoming table, we will see the methods related to console. The input methods such as readline, throw error, if an input errors occurs. Okay. Input methods, read line will read the complete line, and if there is an error, it will return the input output exception. And it is a new IO error, it's a new error exception added by Java 6 and it's a subclass of error class. It indicates that input output failure and it is beyond the control of your program. Because why is it is beyond the control? Because console is not available here. Okay, so you cannot do anything in this case. Beyond the control means you cannot control the particular case. Okay, so there because of Java 6 is adding the console class, it is also adding the error, which is IO error, and it tells that IO failure is there because console is not available or any type of related errors. So you will not normally catch that particular error because you cannot handle it. If an IO error is thrown while accessing the console, it usually means that there has been catastrophic system failure. Okay, the system failures are failures, some types of failures, those you cannot normally handle. Also notice the read password method. These methods let your application read a password without echoing what is typed. Okay, so it will detect what are you are writing as a password and will read the password in a particular variable. When reading password, you should zero out both the array that holds the string entered by the user and array that holds the password that the string is tested. Okay, so you have to first of all clear both two things. Which thing? First is array that holds the string entered by the user, that is user input, first thing, and second thing, add array that holds the password. Okay, which is going to be password that the string is tested against. For example, if ABC is user and its password is stored in array ABC123 and user is entering ABC123. First, if whatever is the variable or array that is tested against, that should be clear first or zero out, and then the array that user is entering as an input. This reduces the chance that malicious program will be able to obtain a password by scanning a memory. and your memory can be hacked. So this type of disadvantage can be eliminated. Okay. So now we will see the methods defined by console class. Flush void flush causes the buffered output to be returned physically to the console. Okay. Then console format, string object variables, write arguments to the console using a format specified by format string. So any format string can be there, %, percentage, percentage, etc. Console printf string format string object variables writes R's to the console using the format specified by format string. Then the reader returns a reference to the reader connected to the console. Then string readline reads and returns string entered at the keyboard. Input stops when the user press enter. When enter is pressed, complete line will be read and saved. The end of the console input string has been reached, null is returned, and IO error is thrown on failure. Okay. So the next is readline string format string object args displays a prompting string formatted as specified by format string and args, and then reads and returns a string entered at the keyboard. Input stops when the user presses enter. That complete readline will be read. If the end of the console has been encountered, null is returned, or reached, null is returned, IO error is thrown on failure. Okay? Failure is catastrophic system failure, and this type of errors we will not handle. Character array read password reads a string entered at the keyboard. Input stops when the user presses enter. The string is not displayed if the end of the console input string has been reached, null is returned. Input output error is thrown on failure. Okay. Then character read password string format string object R's displays a prompting string formatted as specified by format string and R's, and then reads a string entered at the keyboard. Input stops when the user presses enter. The string is not displayed. If the end of the console input string has been reached, null is returned, and input output error is thrown on failure. Then print writer returns a reference to a writer connected to the console. Now we will see the example that demonstrates the class console. Because this is the new class, you will understand it better when you will use it particularly. Okay, so console object is created, and how it is obtained? This is obtained a reference using system.console method. It returns a console reference. If no console available, it will return null, and anything or any IO operation is not available or not possible. Read a string and then display string is equal to console.readline, enter a string. Okay. Then here is your string. Okay, so readline will return a string entered by user, and it will be displayed using the printf method. Why printf method is used? Because you are going to format the string using %s. Okay, system.out.println cannot format the string. Enter string, this is a test, and printf here is your string, this is a test. Okay, so it is a very simple program. When you will use it, you will practice it, you will understand it, and you will learn it better. No need to remember or by heart the program. Okay. Then using string input output. The following example we will see several of Java input output character string classes and methods. Okay. The standard word count command has two modes. If no file names are provided as arguments, the program operates on the standard input string, that is keyboard. And if no or one or more file names are given, the program operates on each of them. Okay. File names means when file names are given, the program will operate on file names. Otherwise, keyboard is used. Okay. So word count example is given. Public static integer words, lines, and characters. Then word count input string reader ISR throws IO exception. C is equal to 0. Then last byte is equal to 2 byte spaces %/t/n/r. Okay. Unless the ISR dot read, that is end of the input, is encountered, we are counting the characters. So what are the characters? these are the characters, integer. Those are added by 1, incremented by 1. Count lines, c is equal to slash n lines plus plus. Okay, so a new line, 9 lines plus plus, integer index white space dot index of character. Okay, so word will be counted by detecting the white space. Okay, so white space will tell a new word has been started. If index is equal to -1, then last white is equal to true, and increment words are incremented, and then words is then updated. Okay, and then last is equal to false. So what is the index? So at every time index is calculated, okay, index is -1, that is end of the white space has been encountered. And last white space means it is the last white space given. Okay, else last white is equal to true. If characters or number of characters is not equal to 0, lines are incremented and then first incremented and then updated. Then we will use the file reader object fr. So standard input rs.length is equal to 0, that is files are not provided. Then we are working with standard input. Word count, new input stream, reader system.in, that is keyboard. So we will whatever is given will be through keyboard. Then else we are working with list of files. Okay. So for number of arguments.length, we are having the file reader object, new file reader args of I. For every file reader, we will word count file reader. So we will count the words of each and every file provided as a variable number of arguments as a public static void main string argument array. Okay, and then return. So next lines, words, and character. Okay, so program will run in two of the any of the one cases. Either we are providing arguments as a file name .txt or etc. Or otherwise, what we are doing, we are providing no arguments. So no arguments are there means we will read the words by console, and we will then count the lines and words. Okay, lines, words, and characters. What WCU method operates on any input stream and counts the number of characters, lines, and words. And it tracks the parity of words and white spaces in the last not white variable. When no arguments, it creates an input stream reader using system.in, that is keyboard. Then this string is then passed to word count, which does the actual counting. When executed with one or more argument, it will handle the files. Okay. So word count assumes that there are files names and creates file reader for each of them, and then reader passing the resultant file reader object to word count method. In either case, it prints the result before executing. Okay. So now we will improve this word count using string tokenizer. Output is not provided because at every case the input is dependent upon you, so output is dependent upon your program. Okay, and whatever the output you will see in the practical part. Then improving word count using string tokenizer. And even better way to look for patterns in an input string is to use another Java's IO classes string tokenizer. Okay, so first of all we have seen that tokenizer before. So better way we will see now to look for patterns, that is string tokenizer. Similar to string tokenizer takes the input stream into tokens that are delimited by sets of characters. Okay, so those characters are special characters like spaces, commas, underscores, and semicolons, and etc. String tokenizer and string tokenizer are similar. Okay, but it is the better way to handle the pattern. Constructor is first is string tokenizer reader input stream. Input stream must be some form of reader. Okay, string tokenizer methods are there. We will use only a few methods of them. Reset the default set of delimiters. We will use the employ the reset syntax method. The default set of delimiters is finely tuned for tokenizing Java programs and is just too specialized for this example. Okay. So default set of delimiters is finely tuned for tokenizing Java programs. Our tokens or words are any consecutive string or of visible characters delimited on both sides of white space. Okay. So what we are declaring, our tokens or words or are any consecutive string of visible characters delimited on both sides of by white space. So before side, that is left hand side, we are having white space. At the right hand side, we are also having a white space. We use the significant method to ensure that new line characters will be delivered as a token, so we can count the number of lines as well as words. Okay. So new general form is significant boolean line, and that will ensure new line characters will be delivered as token. So we can count the number of lines as well as words in that list. If elapsed flag, end of line flag, true end of line characters are written as tokens, and it is false end of lines characters, that is new line characters, are ignored. The word characters methods is used to specify a range of characters that can be used in words. Okay. A general form is shown here. Word characters start and end. Okay. Start and end specify the range of valid characters. Characters in the range 33 to 255 are valid word characters. White space characters are specified using white space characters. And white space characters method is void white space characters start and end. Okay. So start and end will give you range of valid characters. Characters in the range 33 to 255 are valid word characters. And those white space characters are specified using void white space characters start and end. Start and end specify the range. The next token is obtained from the input stream by calling the next token, and next token will return the type of the token. So there are 4 integer constants in stream tokenizer: TT end of TOF, TT EOL, TT number, and TT word. 3 instance variables. Nval is a public double used to hold the values of numbers as they are recognized. Okay. Then S value, the public string used to hold the value of any words as they are recognized. T type is a public int indicating the type of token that has just been read by the next token maker. Okay. So 3 instance variable you have to remember, or you can take a screenshot of this PPT. Okay. So what is the first thing? It is a public double variable nval, public double instance variable, which is nval, used to hold the values of numbers as they are recognized. Okay. Numbers, value, and value. Second is S value, used to hold the value of words or string as they are recognized. And T type is an integer public variable indicating that type of token type that has been just read by next token. Next token will return the token, and T type will give you the type of token. Okay. If the token is word, T type equals to TT word. If token is number, T type equals to token type equals to TT number. As simple as that. If token is single characters, if T type contains a particular value. If end of line has been encountered, T type equals to TT end of line. Okay. Elos end of lines significant was invoked with a true argument. This is the assumption. If the end of the stream has been encountered, T type equals TT end of file. Okay. So file is considered. Okay. So stream can be anything in this case. Word count program revised used in tokenizer we will see now. Here we will not check each and every by is equal to sign. We will directly use the tokenizer. Okay. Words, lines, and characters. PC reader are thrown input exception. Stream tokenizer object is created. New stream tokenizer are. Okay. Reset syntax. And word characters 30 to 55. Okay. Then white space character 0 space. End of lines significant is equal to true. Okay. So we'll take the next token and we will check the type of this. Okay. file, end of file is encountered, what we will do, we will switch to the particular type. If it is end of line, new line is there. So lines are incremented, characters are incremented and break. If it is word, words are incremented by 1 and default characters plus equal to s value, that is value of string dot length. Okay, so those characters are added. Like this is my file. So for each and every characters, this will have the length as 4. In the next time, each will have the length as 2. The next time, my will have the length as 2 and 5 will have the length of 4. So 4 plus 2 plus 2 plus 2 will give me the particular character length in this case. Okay. Then in main method, if r is 0, means there is no file name specified. So WC will pass here input string reader keyboard and print the line, words and characters. Else we are working with the list of files. So T words, T characters and T lines are given. And then in the arguments dot length, what we are doing, we are passing the arguments of I, that is for file reader, we are passing the argument as a file name. Then T words plus is equal to words, T characters plus is equal to characters, and plus is equal to lines. Okay, lines and words, ask of I error. Then total lines, words and characters. Okay. So like in the previous example, same output it will create, but the method we are achieving the output is using string tokenizer. It is not using the normal counter of words, normal counter of new lines, or normal counter of spaces, white spaces, etc. Okay, words, lines, and normal counter of characters. We are using string tokenizer to create this type of output. Okay. Then we will go with the serialization. It's a process of writing the state of object to a byte string. Okay. So what is the serialization? Basically, it is the process of writing the state of object, particularly byte string. Why it is useful? What is the advantage of this? When you want to save the state of your program to a persistent storage area, such as files. What is the state of your program? You want to store to a particular file or a byte string. In the word, by the meaning of your programming language, or it's a byte string, what we will do? We will serialize it. You may restore these objects by using the process of deserialization. Okay. So it is also needed to implement remote method invocation. Remote method invocation allows a Java object on one machine to invoke a method of Java object on a different machine. So what you will do? You will run a particular program. Okay. If there is emergency occurs at any time, any place, what you will do? You will do what? You will save the state of your program, whatever has been done, to a particular file, persistent storage area. And when your emergency case is done, you are coming to your table or your desk next time. You will deserialize it and you will start executing your program by the state of that particular program. Okay. So you will fetch that file again. You will read the state of your program and you will start with the again executing your code. Okay. Object may be supplied as an argument to that remote method. The sending machine serializes the object and transmitting receiving machine deserializes. Okay. So one machine will send the file or any persistent storage and the state of your program, and second machine will read it and deserialize it and then continue with execution of your program. Okay. So remote method invocation we will see in detail in upcoming chapter. Object to be serialized as references to other objects, which in turn have references to still more objects. Okay. We are assuming that object to be serialized has references to other objects, have references to still more objects, and so on. This set of objects and relationship among another object form a directed graph. So one object is referring to another object, another object is referring to another object, and so on. Like in the project, there are multiple classes. Okay, so one class is dependent upon another class. One class is taking a parameter of particular class as an take a object parameter of a particular class object. Okay, so that the particular class is taking the object of another class, and so on. So references are consecutively we are using. So there is a relationship, and that relationship will be among them, or those objects will form a directed graph. So object 1 is dependent upon object 2 is dependent upon object 3, and so on. There may be also be a circular references that is one object is dependent upon another, and another object is dependent upon the first object. Object X may contain reference to object Y, and object Y circularly may contain a reference back to object X. Okay, and also they can contain the references to themselves. Okay, the object serialization and deserialization facilities have been designed to work correctly in this scenario. Okay, so everything is modeled correctly, particularly in any particular situation. So you no need to worry about it. You have to just understand how it is implemented and how you can use in your particular needs. Okay, so you have to just remember it. If you attempt to serialize an object at the top of object graph, all of the other reference objects are recursively located and serialized automatically. You don't need to worry about it. During the process of deserialization, all of these objects and their references are correctly restored. This is the task of your Java virtual machine. Overview of the interfaces and classes that support serialization. We will see the following. Okay, we will see the serializable. Only an object that implements the serializable interface can be saved and restored by the serialization facility. Okay, so not everything, not every class will implement the serializable, and so you will not every class will have the serializable, so it can be saved and stored by the serialization facility. Okay, so it defines no members. Serializable interface defines no members. It's simply used to indicate that a class may be serialized. If a class is serializable, all of its subclasses are also serializable. Variables that are declared as transient are not saved by the serialization facilities. Static variables are also not saved in serialization facilities. So all classes are serializable in this case. Okay. So you have to remember which classes are serializable and which classes are not. Externalizable. The Java facilities for serialization and deserialization have been designed so that much of the work to save and store the state of object occurs automatically. Okay, there are cases in which programmer may need to have control over these processes, so that programmer will decide at which state it will save or at which state it will restore. It may be desirable to use compression or encryption technique. Okay, the externalizable interface is designed for this particular situation. Okay, so compression or encryption technique will give the control to programmer at which state he has to save, or at which state it has to restore the state of the object. Externalizable interface defines two methods: void read external, object input string, throws input output exception, class not found exception. Then void write external, object output stream, throws input output exception. Input stream is the byte stream from which the object is to be read, and output stream is the byte stream from which object is to be written. Okay, so there are two methods: read external, write external. Both is having the object input and object output. Input stream is the stream, byte stream, from which the object to be read, and output stream the byte stream to which object is to be written. Okay. Then we will see object output. The object output interface extends the data output interface and supports object serialization. It defines these methods, not especially the write object method. This is called to serialize an object. All of these methods will throw an input output exception on error conditions. Okay. It extends the data output interface and supports object serialization. Methods we will see in detail, and the particular method write object is called to serialize an object. And all methods will throw input output exception on erroneous condition. Object output stream, it extends output stream class and implements object output interface. Okay. The class we are explaining over here. It is responsible for writing object to stream. Constructor of this class is object output stream. Output stream throws input output exception. Argument output stream is the output stream to which serialized object will be written. Okay. Several commonly used methods we will see in detail. They will throw input output exception on error condition. There is also inner class object output stream called put field. It facilitates the writing of persistent fields, and we will use this beyond the scope of the Java particular course. Okay, so we will not go into detail. We have to just remember there is also inner class called put field in the object output stream class. Okay, so methods defined by object output are void closes the invoking stream. Further write attempts will generate input output exception. Void flush finalizes the output state so that any buffers are cleared. That is flushing the output buffers. Void write writes an array of bytes to the invoking stream. Void write integer offset integer number of bytes writes a subrange of number of bytes from the array buffer beginning at the buffer offset. Then write integer b writes a single byte to the invoking stream. The byte return is low order byte of b. Write object obj writes the object obj to the invoking stream. Now we will see the commonly used methods by object output stream. Void closes the invoking stream. Further write attempt will generate input output exception after close. Flush finalizes the output state so that any buffers are clear, that is, it flushes the output buffers. Void write byte buffer writes an array of bytes to the invoking stream. Void write byte buffer integer offset integer number of bytes writes a subrange of number of bytes from the array buffer beginning at buffer offset. Void write integer b writes a single byte to the invoking particular stream. The byte return is a low order byte of b. Void write boolean b writes a boolean to the invoking stream. Void write byte it write a byte to the invoking stream. The byte return is a low order byte of b. Void write byte string writes a byte representing string to the invoking string. Void write character integer c writes a character to the invoking string. Void write characters strings str writes the characters in str to the invoking string. Void write double d writes a double to the invoking string. Void write float f writes a float to the invoking string. Void write int integer I writes a int to the invoking string. Void write long writes a long to the invoking string. Write object writes object to the particular string. Void write short writes a short to the invoking string. Then object input. The object input interface extends the data input interface and defines the methods. Supports object serialization, not especially the read object method. Okay, write object, we will notice the read object method over here, and this method is called deserialize an object. Okay. Erroneous condition will throw input output exception. Read object also throw class not found exception. Object input stream class extends the input stream class and implement the object input interface. Object input stream is responsible for reading object from particular stream. Constructor is object input stream, and we are passing input stream object, and it goes input output exception. Argument in stream is the input stream for of which this realized object should be read. Okay, so commonly used methods we will see in the table. it throw input output exception on error conditions. Read object method can also throw class not found exception. There is also inner class called getFull, and it reading the persistent field and its use is beyond the full scope of this particular code. So now we will see the serialization example. Following program illustrates the serialization and deserialization. Begins by instantiating an object of class myClass. This object has three instance variable, string, integer, and double. And that string, integer, and double, we will store it into persistent storage area, and then we will store those variables. Okay. Methods by object input are available. Returns the number of bytes that are now available in the input buffer. Void closes the invoking stream. Further read attempts will generate input output exception. Integer read returns an integer representation of the next available byte. Input byte of input. -1 is returned if the end of file is encountered. Read byte buffer array attempt to read output buffer dot length bytes into buffer. Returning the number of bytes that will successfully read. -1 if the end of file is encountered. Read byte buffer integer offset integer number of bytes. Attempt to read up to number of bytes into buffer starting at buffer of offset. Returning the number of bytes successfully read. -1 if the end of file is there. Object reads an object from the invoking stream. Long skip ignore, that is skips the number of bytes in the invoking stream, returning the number of bytes actually ignored. Okay. Then formal use methods by object input stream. Integer available, return the number of bytes that are now available in input buffer. Void closes the invoking stream. Further read attempts to generate input output exception. Integer read returns an integer representation of the next available byte of input. -1 is returned when the end of file is encountered. Integer read byte buffer integer offset integer number of bytes. Attempts to read up to number of bytes into buffer starting at buffer offset. Returning the number of bytes successfully read. -1 is returned when the end of file is encountered. Boolean reads and returns a boolean from the invoking stream. Read byte reads and returns a byte from the invoking stream. Read character reads and returns a character from the invoking stream, and read double reads and returns double from the invoking stream. Read float will return read and return float. Read fully byte buffer array reads buffer dot length bytes into buffer. Returns only when all bytes have been read, otherwise it will return none. Read fully byte buffer integer offset number of bytes. Integer number of bytes. Reads number of bytes into buffer starting at buffer offset, returns only when number of bytes have been read. In integer, read int reads and returns int from the invoking stream. Read long reads and returns long from the invoking stream. Object reads and return object. Read short reads and return short. Read unsigned byte reads and return unsigned byte from the invoking stream. Read unsigned short reads and return unsigned short from the invoking stream. Okay. The file output stream is created, that refers to file name serial, and output stream is created for that particular file stream. Write object is then used to serialize your object. Object output stream is flushed and closed. File input stream is then created, and that refers to the file name serial, and object input stream is created for that particular file stream. So for that, we will see the example, my class. In that class serialization demo, class my class object 1 new my class. Okay, object 1 object new file output stream serial, and then file output stream object output stream will have the parameter as file object string. Then write object 1 flush and close. Exception during serialization if there is any. Then object deserialization, the file and output stream serial. Okay. Then object input stream will have the parameter file input stream, and read object will read the object cast to my class and save into my class object 2, and then object dot close. Okay. Now main class that implements serializables S, I, and D we will store and read. Okay. So S, I, and D are the parameters constructors. These are instantiated. S is equal to S, I is equal to I, D is equal to D. Okay. So this program demonstrates that the instance variables are identical. S object 1 is hello, I -7 D 2.7, E10 object 2 S hello, I -7 D 2.7 E10. Okay. The same object is saved into serial and same object is deserialized. Okay, this is the input we have passed to save into, okay, serialize, and this is for deserialization. Okay, exception during deserialization. And these parameters can vary dependent upon you. You can pass any parameters. You can pass any number of parameters. You can pass same parameters like integer, anything. What is the main motto of this program? You will save the state of your program into persistent storage area, that is file, and you will restore it when you are again come to your desk. Okay. Stream benefits. So what are the benefits we have understood till now? We are learning the Java input output in the previous session. In previous chapter also we learned a lot about it, and here also we learn a lot about it. What is the benefit? Now we will see them. Streaming interface to input output in Java provides clean abstraction for complex and often cumbersome tasks. Okay. So abstraction is provided first of all. Composition of the filtered stream classes allows you to dynamically build a custom streaming interface to suit your data transfer requirement. Okay. So filter stream classes dynamically they are provided. Okay. So you will take a particular class depending upon your requirement. So there are number of classes designed as per your requirement. Java programs written to address the abstract high-level input stream, output stream, reader and writer classes will function properly in future, even in new improved appointed classes are invented. Okay, this we will see in the next chapter. This model very well works when you switch from file system based of set of streams to the network and software stream. Okay, new classes will be there, new classes will be arrived, but still file system will still be there. Finally, serialization plays an important role in many types of Java programs. Java serialization input-output classes provide a portable solution to this sometimes difficult task. So this way we have ended with our class or chapter regarding input-output in detail. Okay. So in the next session, we will see the practical examples, all practical examples, how they are implemented actually, programmatically. And after that, we will start with the new chapter. So meet you in the next session with the practical examples. Thank you so much.